Good evening, class. Happy Monday. Welcome to another session. And today we all know what we are here for. We are here for chemistry. And in today's class, we'll be considering a new topic. Trust your day went well. Trust your weekend went well. It was a long week, 2 weeks. Last Monday was a public holiday. Hope you utilized the time well. And so let's start this class. Today's class, the topic is acid, base, and salt. Acid, base, and salt. I'm very certain that nobody here is okay. The mic is working, right? It's changing color. All right. Okay. Sorry about that. Okay, so nobody here is not familiar with the word acid, base, and salt. We all know what we are here for. We all know what it's about. So let's just breeze through it and then go to solving of past question. What is acid? When you hear the word acid, what comes to your mind? Sour taste, orange, lime, lemon. That's correct. By definition, acid is a substance which in aqueous solution produces hydronium ion as its only positive ion. That means acid is that substance in its aqueous solution. You all know what aqueous solution means, right? Produces hydronium ion, that is H3O plus, as its only positive ion. Positive, that's the only cation, right? That's the only cation. So let's consider some classification of acid. You can classify acid based on their source, or rather you say origin. So let's just talk about classification. We're considering it under three. We'll consider based on source, or let's say origin, right? We'll also consider based on the degree of ionization in water, and we'll also consider based on concentration. Based on concentration. Let's start based on origin. When we talk about origin, we also mean source. That means where do you get P form? Because under this classification, we can consider organic acid and inorganic acid. Organic acid, right? And inorganic. When you hear the word organic acid, what comes to your mind? Something that you can get from either plants or animal. Either plants or animal. That's when we talk about your lactic acid. And lactic acid is for milk, right? We talk about malic acid. Malic acid as apple. We talk about citric acid. Citric acid, you're talking about lime, lemon, and also talk about ascorbic. Ascorbic is then your orange. So basically for organic acid, acid found in plants. I just speak up for myself. Okay. So we've, we've considered origin and we talked about organic, and before that I apologize for the breaking transmission. So let's continue. Okay, so we've talked about organic and inorganic. Inorganic are synthesized in the laboratory, organic and found in plants and animal, right? Concentration, we talked about diluted and concentrated, right? And also for degree of ionization, that means how does it dissociate in water? Strong acid dissociate completely in water, whereas weak acid do not completely dissociate in water. Example of strong acid is H2SO4. That's acid that dissociates completely in water. Weak acid, you have acetic acid, right? Yeah, that's CH3COOH. Acids that do not dissociate completely in water. And so we've talked about this, right? Now let's talk about some of their properties. We consider few of physical properties and also chemical properties. So let's consider properties. This is just to walk you through, right? And then we'll be able to, all right. So physical, we've all heard the term acid turns blue, litmus red. I'm sure you that this is not the first time you're hearing that acid turns blue, litmus red. That means litmus in acidic medium will be what color? Red, not blue. Acid turns blue, litmus red. That means the resulting color is red. So when you're asked what's the color of litmus paper in acidic medium, it is red, not blue, because acid will turn the blue to red, and so the resulting color is red. And so that's one of the property. Weak acid, or let's say dilute acid, have sour taste. Dilute acid have sour taste. I use the word weak. They usually have sour taste. They have sour taste. And so I've considered two properties, right? And they also conduct electricity. Acid conduct electricity. Acid conduct electricity. Let's talk about the chemical properties. I'm sure you know the term neutralization reaction. That's one of the chemical property of acid. And neutralization reaction basically means the reaction of acid and base, or you say alkaline. The reaction of acid and alkaline to give salt and water. Reaction of acid and alkaline, acid plus alkaline, or you say base, to give salt plus water. This is what we call neutralization reaction. Acid also reacts with metal to liberate hydrogen gas. Acid plus metal will liberate hydrogen gas. Acid reacts with metal to liberate hydrogen gas. Acid also reacts with carbonates to liberate CO2 gas. Acid also reacts with carbonate to liberate CO2 gas, right? And so I've talked about some of the physical property and also the chemical property. The important chemical property is one, neutralization reaction. That's reaction with alkaline to the salt and water. Two, the reaction that leads to the formation of hydrogen gas, to the liberation of hydrogen gas, and that's with metal. The third one is reaction with carbonate to liberate CO2 gas, right? To liberate CO2 gas, and that's where you see your effervescence, That's why you see a Fabi sense. So let's talk about some of the uses of acid. Uses of acid. Fatty acid is used in production of soap, right? H2SO4 serve as a bleaching agent. So it can be used as a bleaching agent or a cleaning agent, right? And so basically, any acid you know and what is used for, just write it as one of the use of acid. Fatty acid, you also use citric acid in the manufacture of fruit juice, right? Because lime, of lemon and lime. And so these are uses of acid. Any acid you can remember, anything is you know it is used for is one of it. So you just write that acid and you write the use. That's all. So fatty acid can be used in manufacture of soap. H2SO4 can be used in the manufacturing of bleaching agents. Even nitric acid can be used in the manufacturing of urea. Excuse me. Also, fertilizer. Fertilizer. That means acid that has nitrogen compound. Be used in the manufacturing of fertilizer. Okay, I think we are good on that note. Let's talk about base briefly. Let's talk about this. Nice one. Okay, so okay. So before we move here, let me quickly touch basicity of acid. Sorry about that. Okay. Basicity of acid. When you hear the word basicity of acid, is the number of replaceable hydrogen ion in one molecule of an acid. The number of what? Replaceable hydrogen ion is the number of replaceable hydrogen ion in one molecule of an acid. Let me give an example so that you understand what I mean. HCl, hydrochloric acid, has one replaceable number of hydrogen, one, and you call it mono acid. H2SO4, tetrahydrosulfate 6 acid, has two replaceable hydrogen ion, and it is called diacid. H3PO4 has three, and what would it be called? Definitely tri. And so basically, let me expand this. H2SO4. So dissociation of this will give this, and so this is the number of replaceable hydrogen ion. So when you hear basicity of acid is the number of replaceable hydrogen ion in one molecule of an acid. Okay, so we can move to base. Base is basically that substance that neutralizes acid to give salt and water. Base is that substance that reacts with acid, right, to give salt and water. I'm sure you would have heard where when someone complains about um heartburn, indigestion, you hear them say, oh, use antacid. Why? Because it has OH, right? And so base is that substance that when it reacts with acid, we give salt and water. And when such person uses the antacid, the person with time will be eased of the pain. And so base is that substance. That's just the definition. Base is the substance that what that when we react with acid gives salt and water. And it also has a classification like that of acid, where we talked about origin, right? We talked about origin, we talked about degree of dissociation, degree of ionization, right? And also concentration. And so acid can also, base rather, can also be broken down into this category. And so if you are then ask what's the difference between acid and base. You know, for acid, I made mention that it turns blue litmus red. Acid turns blue litmus red. That means in acidic medium, litmus will have red color. For base, it turns red litmus blue. Base turns red litmus blue. So what is now the resulting color of litmus in a basic medium? It would be blue, because base turns red litmus blue. It also has soapy feel. That soapy feel is bitter in taste. Bitter in taste. These are just some of the properties of base. These are just some of the properties of base. And I've also considered the classification of acid, and you can then use that in play also for base, right? And so let's move really fast. So let's move on to, okay, salt. Let's move on to salt. Let's move to salt. I've talked about properties, right? And chemical property. Chemical property of neutralization would also play here. Neutralization reaction, which I made mention when I was explaining that of acid, that acid reacts with base to give salt and water. So you can use it as one of the property of base, because base would also react with acid, is one of the reactants that would give salt and water. And so these are the physical properties. Let's now move on to salt. Uses, really quick. Uses. Battery. I'm sure you've heard of alkaline battery. You've heard the word of alkaline battery. Alkaline base, they are used interchangeably. One is soluble in water, one is not soluble in water, but for your, just know that they are used. So alkaline battery is a product of base, right? And so let's move on to salt. Salt. When you hear the word salt, what comes to your mind first? Table salt. Table salt is just one of the numerous kinds of salt. Table salt is just one of the numerous kind of salt. Salt in chemistry is more than table salt. It's more than Dangote salt. I don't know, Mr. Chef salt and all of that. So it's more than all of those salts you use in the sea salt. Is more than that, what you use in the kitchen. Salt in chemistry would mean, or means rather, salt in chemistry means the product of neutralization reaction. Salt here means product of neutralization reaction. And salt, not all salts are white in color. There are different colors of salt. You have copper salt, and copper CuSO4, which has blue, right? It's also a salt. And so salt, not all salts are white in color, and is a product of neutralization reaction. Product of neutralization reaction. Now let's consider types of salt. Types of salt. Types of salt. Under which would we have normal salt. Here, all the replaceable hydrogen ion in the acid have been replaced by OH. Don't forget that neutralization reaction is reaction of acid plus base gives salt. So if this is HCl and this is NaOH, this would result to what? NaCl plus H2O. The acid here has one hydrogen ion, one replaceable hydrogen ion. And so there are cases where, as we made mention here, we have di. So we know that there are some cases that the number of hydrogen ion in the acid will be more than one. So for normal salt, all the replaceable hydrogen ion have been replaced. All the hydrogen ion in the acid have been replaced by OH, right? You notice it moved from this to this. This is HCl and this is NaCl. That means this and this has this has been replaced by what? This. And this comes here. This comes here. The chlorine and the sodium, the hydrogen and the OH. So all of the replaceable hydrogen ion have been replaced. Then we talk about acid salts and basic salt. So I really want to say something here. For acid salts, example, this is a salt. Let me give example so that we can understand what I mean. Okay, NH2HPO4. Okay, ZnOHCl. For normal salt, all of the hydrogen ion have been replaced by the metal. Let me take the explanation again. HCl plus NaOH will give NaCl plus water. It moved from this to this. What's the difference? Chlorine is here, right? Hydrogen is here, sodium is here. That means this hydrogen has been replaced by the sodium. And we know sodium, to be in group 1, it is a metal. So here, the hydrogen has been replaced completely by the metal ion. And where did the metal ion come from? From the base, right? The hydrogen ion is from the base. And so for normal acid, all of the hydrogen ion would be replaced by the metallic ion in the base to give the normal salt. For acidic salt, not all of the hydrogen ion would be replaced in case of this. So the difference between a normal salt and acidic salt is that there will be H. Don't forget we're talking about the hydrogen ion. You would see H in the middle of the two sides, the metal from the acid and also the anion from the metal from the base, rather, the anion from the acid. You will see hydrogen in the middle. That signifies is acidic salt. That signifies is an acidic salt. For basic salt, let's go back here again. The difference between this and this is that there is OH here, there is OH here. Is that the sodium here have been replaced by hydrogen. The hydrogen here is 2, hydrogen here is 1. That means there's an increment. Are you following? That means there's an increment in hydrogen. Oxygen here is 1, oxygen here is 1. Sodium is here, sodium is not here. That means, what does this suggest? That means the ion right? The metal has been replaced, right, with hydrogen. The metal has been replaced by the positive ion from the acid. Don't forget this is the acid. And so for basic salt, not all of the OH would be replaced. You know, it's moving from here to here. Not all of the OH would be replaced. So the difference between normal acidic and basic salt is that for normal salt, you wouldn't see H or OH because they will replace completely. Acidic salt, you will still see hydrogen in the compound. That suggests that not all of the hydrogen ion are being replaced. For basic salt, you will see OH in the compound. That means there is still OH in the salt. Don't forget, when we talk about salt and acid, basically, we are talking about hydrogen and OH because this is where the water is formed. And the hydrogen, which is from the acid, the OH, which is from the base, right? Hydrogen from the acid, OH from the base. And so when we talk about acidic salt, it still has hydrogen in the compound. Basic salt still has OH in the compound. And so when you see a list of salts and they tell you to remove the odd one, you just know that the one that has hydrogen represents the acidic salt, the one that has OH represents the basic salt. The salt that does not have hydrogen or OH is the normal salt. Let's move on. Let's also talk about double salt. Double salt is the salt that usually would have long, let me give an example to it, long name, right? NH3, okay? NH4, 2, Fe, SO4, 2. Is that correct? Yes. This is ammonium ion 2 tetraoxo sulfate 6 heptahydrate. Let me take that again. Ammonium ion 2 tetraoxo sulfate 6 heptahydrate. Don't worry yourself about the name or examples of the salt. Just what you should know for double salt is that it has multiple ions. It usually has 3 ions. Here we have ammonium, right? We have ion and we have sulfur group as well. So for double salt, we're talking about salt that has multiple ions, like 3 ions. And so anyone you see that has long chain, that has various ions, we suggest double salt. Complex salt. Complex salt would be salt that has a complex ion. And we've talked about ion in this class. They are charged atoms. So when we talk about complex ion, that means group of ion coming together. That means group of compounds coming together that have a charge on it. And so let's go through it again. We have normal salt, acidic salt, basic salt, double salt. We know double salt has 3 ions, different ions in that. And complex salts will have a complex ion. So we're good. So let's move on fast. We'll talk about a very peculiar reaction concerning salt, and that is hydrolysis. Hydrolysis of salt. Hydrolysis of salt basically means when you hear the word hydrolysis, we are talking about water, right? Hydro. We are tending towards water. And so hydrolysis of salt is the reaction of salt and water. The reaction of salt and water. I'm sure this looks familiar to one of the reactions we've spoken about in this class. And this would be the product, and this is the product of neutralization reaction. Acid and base give salt and water. So salt and water will give what? The inverse, that is the acid and base. And so we can say for neutralization reaction, to be the inverse of hydrolysis of salt will be the inverse of hydrolysis of salt. Okay, let's move on. Let's move on. Let's move on. Okay, 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 okay. Okay. I forgot to talk about two other salts here, and we've also considered it in one of our class. Hydrated salt and anhydrous salt. In our class, when we talked about water of crystallization, can you remember? Right? I said a salt to have a certain molecule of water. So that molecule of water is the water of crystallization. So salt that has water of crystallization is called hydrated salt. Salt that does not have water of crystallization is called an hydrous salt. Salt that does not contain water molecule. Are we together? So we are fine on this. So we can move on to our hydrolysis of salt. I said it's the reaction of salt and water, and is the inverse of neutralization reaction. And so from hydrolysis of salt, it can be divided into two. It can be basic, it can be basic, it can be acidic. So when you dissociate the salt and you get strong acid, don't forget this is coming from acid and base to give salt and water. And so when this gets dissociated and then returns to acid and base, when you get a strong acid and a weak base, you say it is acidic. When the result leads to a strong base and a weak acid, you will say is basic. Let me take that again. When the salt and water results to the salt and water reaction results to a strong acid and a weak base, you say it is acidic in nature. When it results to a strong base and a weak acid, you say it is basic in nature. Okay, so from there we'll then move on to the calculation part of this topic. I want to believe that I'm not too fast. I know I'm kind of fast today, but please bear with me so that we can cover up on time. We lost a class due to public holiday, and so let's do it to cover it up. When you hear pH scale, I'm sure we know what that means, right? You've heard it before. Like it's a numbered scale, and it's just basically used to measure the acidity or the alkalinity of a solution. It's used to measure the acidity of alkalinity of a solution. It's used to measure the acidity or alkalinity of a solution. As I said earlier, is a measured scale. That means pH scale is from 0 to one other 0 to 14, and the middle is 7. The middle is 7, and so anywhere here is considered to be acidic. It's a measured scale from 0 to 14. 0 to 14. And the middle of 0 to 14 is 7, right? And so 7 downward is acidic, 7 upward is basic. Here is neutral. 7 is neutral, 0 to 7 is acidic, 7 to 14 is basic. So in the course of this class, we talked about strong and weak acid, right? Strong acid weak acid. When you move towards 7, you're moving towards neutral. When you are close to 7, before you move 10, 11, like 7.1, 7.2, you're still towards acid, right? You're still towards neutral, right? And so for acid, strong acid have lower value of pH because it should be somewhere here. When it's moving here, it's already going towards neutral. And so weak acid will take 6 point something thereabout, and strong acid will be around 1, 2, 3, right? And so for base, it is the other way around. This is towards neutral, and this is going to extreme. So for strong and weak base will have values close to 7. Weak base will have values close to 7, whereas strong base will have values towards 14. Do you understand that? Okay. So it has value close to 14. I said, no, what is pH itself? What is pH? pH is potential of hydrogen. We've talked about the scale. Now let's talk about pH itself. pH, the full meaning of pH is potential of hydrogen. Then what is it by definition? It is the negative logarithm of hydrogen ion concentration to base. Then the negative log of hydrogen ion concentration to base 10 or base of 10 to base 10 is the negative logarithm of hydrogen ion concentration to base 10. So we can write it as this: pH is equals to minus log of hydrogen. Because we say it is the negative, don't forget this sign, the negative. Okay, sorry. The negative log of hydrogen ion concentration, this hydrogen ion concentration to the base of 10. Are we together? Okay. So POH will then be the inverse. This is H, right? And so we are considering hydrogen ion. So POH will be the negative logarithm of hydroxide ion concentration to base 10. The negative log of what? Hydroxide ion concentration to base 10. The negative log of hydroxide ion. Don't forget for pH, it is hydrogen ion. While for pH should be hydroxide ion. And if we write it like this: pH equals to minus log OH, right? pH minus log OH. Okay, so let's move fast. We can say pH plus POH is equals to 14. Don't forget our scale. Our scale is from 0 to 14. And so we can say hydrogen ion concentration and OH minus concentration will give 10 raised to power minus 14. Our scale is 0 to 14. So the potential of hydrogen and the potential of hydroxide will give 14. Whereas the concentration will give 10 raised to minus 14, because this is as a result of the minus log. And so anytime we are asked to calculate and we are given a concentration, the first thing to determine is what type of acid is it, or what type of base is it. We made mention of basicity of acid, where I said that is the number of replaceable hydrogen ion, right? And so if you are given a diacid, that means acid that has two replaceable hydrogen ion, and you are given a concentration, you have to multiply it by the basicity. So if it is mono, so you multiply by 1, you get the resulting value. If it is di, you multiply it by 2 so that you get the resulting value. Let me put that into context. Let me put that into context. Okay, we're still good with time. We're still good with time. Okay. Find the hydrogen ion and hydroxide ion concentration in a 0.001 sodium hydroxide solution. B 0.2, this is molar, 0.02 tetraoxosulfate 6 solution. That's to have acid solution. Okay, so let's work with this. I told to find the hydrogen ion and the hydroxide ion concentration. In A, we are given the molar sodium oxide, hydroxide, B, tetraoxosulfatic acid solutions. In a particular class, I made mention that if you don't know formulas, if you cannot convert the name of an acid or any compound given, if you cannot write the chemical formula, there's no need to continue because you will not know how to go about it. We're not told to the order, we're just told to calculate hydrogen and that of hydroxide. The first compound, sodium hydroxide, the first thing to write is the formula. Tetraoxosulfatic acid, the formula. In that way, we'll be able to know if it is monoacidic, is it diacidic, how many hydrogen ion that is, let me take that again. How many replaceable hydrogen ion does it have for acid? If it is for base, how many OH ion does it have that can be replaced? So the first thing is sodium hydroxide. Don't shatter my heart this evening. Sodium hydroxide, what is it? What's the formula? What is the formula for sodium? Thank you very much. Because I'm avoiding you now. Okay, tetraoxosulfatic acid. I'm listening. I'm waiting. It starts with H. H2SO4. Okay, this is OH. So we know that this concentration is not hydrogen ion concentration, rather it is OH concentration. Why? Because of the compound. So let's solve. Sodium hydroxide, which is NaOH. So we know this molar concentration is for OH, not for hydrogen. If you don't know the formula, there's no way you can know whether it's for hydrogen or OH. Since we know the formula, that is sodium hydroxide, right? So we know that this molar concentration is the concentration of OH. So we can just say for A, hydroxide ion is 0.001 molar because it has only one of this, so we know that it's multiplied by 1. So we are now left with calculating hydrogen area. At any point you don't understand, let me know. We'll then come back to this formula. Anyone on the call, please, if you don't understand, please let me know so that we address this easily, right? So that we can move on. These are questions that should not take you max 1 minute. I'll be able to move on and there are few questions mark, because this is the only thing you need to know. Once you know this, you are good to go, right? And so, battle to calculate hydrogen area. You know this formula. Formula question, we're already given this one. So we have to calculate this one. So what do? Let me rewrite this. This is hydrogen plus OH minus will give 10 raised to power minus 14. We know this. So let's make hydrogen concentration subject of formula. So hydrogen ion concentration is then equals to, we divide both sides by OH, right? In order to make hydrogen ion concentration. Let me use it. So this is it. OH minus will give 10 raised to power minus 14. We already know OH, we're looking for hydrogen. So let's make hydrogen the subject of formula. What would we do? We divide both sides by OH. This will cancel this, we are left with this. So hydrogen ion concentration is then 10 raised to power minus 14 over OH concentration. And then this is 10 raised to power minus 14. We're given this in the question. 0.001, 0.001, right? And that is 10 raised to power minus 3. 10 raised to power minus 3. This is 1, this is 1, this is 2, this is 3, right? So if you take it this way, if this is 0.001, right? And so if you take it from this decimal point, 1, 2, 3, so it will become 1 times 10 raised to power minus 3. And so let's move on. I'm doing this in case we're given is 0.001. Can I continue? Thank you. So we can work with this. From that should be law of indices, right? When we take this one, it become minus, right? So this is 10. This is minus 14. If this comes up, it will be minus into minus 3. You agree? You agree? Okay. Thank you for agreeing. And so this is minus 14. Minus times minus will be plus, right? Plus 3. Minus 14 plus 3 will be minus 11, right? And so the answer is 10 raised to power minus 11. Are we good? Okay, that's good. So we've already calculated that of hydrogen. We're given hydroxide in the question, hydrogen ion concentration. That is it. So that's all about the questions. Let's move on to the second aspect. In case, let me just do that so that we know that we did it for the whole question, so that we can conclude this part today. Just in case you are then asked to find the pH and the pH. We already know the hydrogen ion concentration, right? We already know OH concentration. And we know that pH is equals to minus log of hydrogen ion concentration. And pOH is equals to minus log of OH minus, right? And so from our value here, we can determine the pH. So let's determine the pH. That will be minus log of this value, and that is 10 raised to power minus 3. pOH will be minus log 10 raised to power minus 11. So let's calculate that. That was a mistake. Then this one minus 3 is for OH. So this is POH. And this is for hydrogen. So this is PH. Let's press that on our calculator. Minus log 10. I'm sure we know how to use our calculator for this. Okay. And so this is 3. And this is 11. How to cross-check that? We know that pH plus POH must give you 14. 3 plus 11, is it 14? Yes. So let's try the second one. B. Find the hydrogen ion and hydroxide ion concentration in this. And we know it is H2SO4. That means this value is for OH. It's for hydrogen rather. This, you knew the value was for OH because of the element, the compound. Here it's for hydrogen ion. There's another thing to confirm. What type of acid is it? Is it monobasic or dibasic? And H2SO4 is dibasic. Because it is dibasic, we have to multiply it by 2. So that concentration, the first thing we can calculate is hydrogen ion concentration, right? So that value, which is 0.02, we have to multiply it by 2. Why are we multiplying it by 2? Because of the compound, because it is dibasic. And so this will give 0.04 molar. And so that's the concentration of the hydrogen ion. Now let's find the concentration of the hydroxide ion, OH minus. And how do we find it? Let's just go straight to this place. Or no, let me do it again for those that didn't understand it there. How do you find this? Right? We know that hydrogen ion and OH will give 10 raised to power minus 14. This is a constant. There's no need to calculate it. Don't bother yourself calculating the formula. Just know it as one of the 2 formulas in pH scale. So with this knowledge, we can make OH the subject of formula. What do we need to do? We divide it by the value beside. And what is beside it? Hydrogen ion concentration. So divide this by hydrogen ion concentration. Divide this by hydrogen ion concentration. So this will divide it, right? By let's do this. So OH then will be 10 raised to power minus 14 H. Are we good to go? Okay. We know the value here, so we can impute it. So this 10 raised to power minus 14 divided by 0.04. And this can mean, what can I use? Okay, so let me try to be here. 0.0412. Can it mean 4 times 10 raised to power minus 2? Is it the same thing? Yes. Okay. All right. So if you agree that that is the same, we can then use here. Just I'm doing all of this in case you don't have a calculator to yourself. Because what I now want to write now is, let me clean this upper part. What I want to do here will now be 10 raised to power minus 14 divided by this 4 times 10 raised to power minus 2. Right? Don't forget that we can put 1 here. This and this doesn't mean the same. Do they mean the same? Thank you for knowing this. Thank you very much. And we know that 1/4 is 0.25, right? So we can just, this would also mean 1/4 multiplied by 10 minus 14 minus, let me take it down so that you see it. This would mean 1 over 4 multiplied by 10 raised to the power minus 14 minus 2. This minus is coming up, and because it's coming up, there'll be this negative sign there, right? And minus 2. Thank you. So this is 1 over 4 multiplied by 10 raised to the power minus 14 plus 2. And this is minus 12. So that is, I will still use my calculator. 1 over 4 multiplied by 10 raised to minus 12. 1 over 4 is 0.25 multiplied by 10 raised to power minus 12. Hope I'm not confusing you yet. Thank you. From here, if this comes here, it will be 2.5 times 10 raised to power minus 1 times 10 raised to power minus 12. Abi? And so let's now use our calculator to confirm. To confirm, 10 raised to power minus 14 divided by 0.04. Yes, we're good. Can you see? You can solve this without calculator. So in case you say, oh, I'm in exam hall, I'm writing Jamb, there was no calculator, that's why I couldn't solve it. That is not true. Work with speed, work smart, work well. Like, you can get the answer from it. I did all this so that you understand it, but straight up from here, you can know that this is 1 over 4. So when this one comes up, it becomes 12. 1 over 4 is 0.25. Once it moves to 2.5, that's minus 1. Minus 1 plus minus 12. Minus plus. Minus times plus minus. So that is this, and it give this, right? And so that is the answer for this. And so we've gotten the first answer and the second answer. So the way we solve the pH and the pOH for the initial one, let's try it here as well. So pH is equals to minus log of this value, which is 0.04, and this is pOH minus log 2.5 times 10 raised to the power minus 13. The answer we get to write here. So let's do that. Minus log 0.04, that's 0.4 minus log 2.5 times 10 raised to the power minus 13. This is 12.6. 12.6. Please don't forget this negative logarithm. The definition of pH is, it is the negative logarithm of. So don't forget that term negative, right? And so the first one, minus log. So when you are inserting it in your calculator, you write this is 1.4. 1.4 plus 12.6 will give you 14, right? And so that is that about that. So we've answered 2 questions. So we are done with everything about pH and pH. And from here, we didn't use more than, I'm trying to create space somewhere, somehow. Okay. We didn't use more than these 2. Can you see here? I don't know if you can. Okay, they'll be able to see. We didn't use more than these 2 formulas. OH minus equals to 10 raised to the power minus 14, and pH plus pOH equals to 14. We didn't use more than these 2 formulas. Those are the 2 formulas required for pH scale. Any question at this junction? No question. Okay. So the next thing from here is indicator, but I would take my time on that. So that will be addressed in the next class. So at this junction, we've come to the end of today's class. Thank you all for being here. I'm very certain you've learned from today's class. At any point, if you have any question, please do it to reach out to the right channel. You all know your group chat, type the question, you'll be responded, you get your response soonest, and the earliest possible time. And please, this is already April. All O levels exams should start April, May, right? Is it GC? There's GC in May. Neco should be May. Neco should be, I think, June. Um, Waec is May, right? Waec is May. Jamb should be this. Waec is this month. Have they started Waec? Oh, they started Waec. Yeah, it's this month. And and what's it called? Jam should be this month as well. So please do well to brush up everything you need to do, and success is attainable. Thank you. See you in the next class. Oh, it's not here. Where's the guy?